My dear students, welcome back to the lectures of formal languages and automata theory. In this video lecture, we are going to discuss an example related to Turing machine. In the previous video lecture, we have seen an example problem regarding Turing machine for the language L equal to A power n, B power n. But here the language is A power n, B power n, C power n, where n value is greater than or equal to 1. We will see now how we are going to solve this problem and how we will construct a Turing machine for this. Let us see here. Let us consider n value equal to 3. We will consider n value equal to 3. So that's why we have taken 3 A's followed by 3 B's followed by 3 C's. And I told you already blank symbol will be there, and the use of starting blank symbol is it indicates that the use of actually here we have taken blank symbols. We have taken blank symbols here in the beginning, and also at the end also we have taken blank symbols. Actually, we can denote a single blank symbols, or you can define any number of blank symbols. And whatever the string you take, that must be enclosed between blank symbols. These starting blank symbols are defining the starting blank symbols are telling us that string has not yet started, and these blank symbols at the end gives us the meaning that the string has been ended. I told you in the previous example also. So we'll see now how we are designing a machine. So when similar to our previous example, here we are going to scan our first input symbol small a, and we have replaced that small a with capital X. And after that, if any number of A's are encountered, we will not change that. We will not replace anything in the place of small a. We will directly go for searching another alphabet. Suppose if another symbol B is found, we will replace that B with some other variable. Here we have changed that. We have replaced Y in the place of small b. And after that, if any number of B's are encountered, we will not worry about that until a new symbol is found. We will keep on scanning the input to the right position. So like that we will do, and whenever C is encountered, and we will replace that C with Z. We will replace the C with Z here. We have also shown that step. See here, we have replaced that C with Z here. Okay. This is how we are going to solve this. And you observe this Turing machine, how the meaning of Turing machine is. Suppose the starting input symbol is, when we are in the state Q0, and when the input symbol is A, replace that A with capital X and move in a right direction. That is the meaning of Turing machine transition. As I told you, in the starting symbol is input symbol, middle symbol is symbol which we are going to replace, and this indicates the direction we are moving. So similarly, after that, if any number of B's are encountered, we will keep on moving right direction. And what we will replace, if A is identified, we will replace small a only. That means we are not changing any symbol. We will keep that A as it is, and we will keep on moving in a right direction until a new symbol B is found. Once B is found, we will replace that B with capital Y, and we will move to the right direction. And you see here in the next step what we have done. And after that, if any number of B's are found, we will not change those symbols. We will keep on move right direction without changing those symbols, without replacing anything, until a new symbol C is found. When a new symbol C is found, we will replace that with Z. After that, we will not. What we will do here, we are not moving to the right position, right direction. We are coming back. We are coming back in a left direction. See here, wherever a C is, you see here in the next step we will understand. You see here, when C is found, and we are replacing that with capital Z, and we are not moving right direction. We are moving in a left direction. And consider we are in the state Q3. And when A is identified or B is identified, when A is identified or B is identified, we are not replacing anything. See here we B in the place of B also we are not replaced anything until, see, in capital Y also. If capital Y also we are not replacing anything. We are just moving left direction. Just we are moving in a left direction. That's it. We are not doing anything until we will find the symbol X. If X is identified, replace that with X and please keep we'll move to the right direction. Suppose if X is identified, when we keep on scanning on the left side, when X is identified, now what we will do from there onwards, we'll move to the right direction, and after that one more symbol will be there, right? When we move to the right direction, A will be identified there, small a will be there, and we will rename that small a with capital X, and we will keep on moving in a right direction. Like that we are going to move here. So this is the diagram, you can understand very clearly. So after that see here, when we are moving in a right direction, if Y is identified, we'll replace that Y with capital Y only, we will not do anything. And A is identified, we will not replace that with anything. Only if B is identified, only small b is identified, we will replace that with capital Y and we will move in the right direction. So that is what we are doing, and see the same thing until this is the last step, right? This is the last step until the last step is here. This is not the last step, but the last step is we have to change all the symbols, all the A's into X's, all the B's into Y's. Here we have not changed this B into Y. We need to change that, and we need to change all C's into Z's. Once it is completed, we will understand that there is no input string to change. So in such a way we are identifying. So if we are identifying one small a, and we are going to identify one small b, we are going to identify one small c. After that we are coming back again, we are identifying another small a. Like that we are counting whether the string is given with equal number of a's or b's, or we are finding that, okay, whether the string is given with equal number of a's or b's, that we are finding here. So this is how we are going to do here, and please try to understand the Turing machine which is constructed here. So based on this, I told you, right, very simple problem it is. What we are doing here, we are just moving, we are just scanning the first input symbol, small a, we are moving to the right direction until a different input symbol is encountered. If small b is encountered, we will change that small b with another symbol, and until after that if any b's are found, we will not change that until we reach the another different symbol. If C is found, we will replace that C with capital Z, and after that if any input symbol is there, we will move forward. If no input symbol is there, we will come backward, we will come in a left direction until we will see the capital X. Once capital X is found, from there onwards what we will do is we will find out is there any small a symbols are there, like that. So this is how we are going to do here. Please try to understand and let me know if you have any doubts. I'll stop this teach. We'll meet in the next example problem.